Today, Yellowstone stirred again. A series of earthquakes surprised scientists. Is this just natural activity, or an early warning of an eruption by America's largest supervolcano? The USGS U.S. Geological Survey reported a new series of earthquakes in the early hours of this morning, with magnitudes ranging from 2.1 to 4.3. Most were centered near the Norris Geyser Basin, one of Yellowstone's most geothermally active areas. Earthquakes in Yellowstone are typically caused by the movement of hot fluids and gases within the Earth's crust, but when they occur in large numbers, called a swarm, they can indicate pressure from an underground magma chamber. Yellowstone isn't just a national park, it's a dormant supervolcano, and every little movement could signal major activity beneath the surface. If Yellowstone does erupt, the impacts won't be just local. Volcanic ash could blanket the American West, disrupting aviation, agriculture, and even the global climate. However, it's important to note, today's earthquake is not a sure sign of an impending eruption. Yellowstone experiences hundreds of small earthquakes every year. Researchers from the Yellowstone Volcano Observatory say that despite the increased activity, there are no significant indications of a major eruption. The volcano's status remains normal. However, they are continuing to monitor magma movement, aftershocks, and ground deformation in real time. Yellowstone is a sleeping giant, and today it's stirred. Is it just a stretch, or the beginning of something bigger? Time will tell. On the other hand, Yellowstone, a giant magma explosion that could change the world. Imagine a force hidden beneath the Earth's surface that secretly stores the energy equivalent of thousands of nuclear bombs. This place isn't a science fiction movie. This is real. This is Yellowstone. In this video, we'll explore the terrifying power behind the Yellowstone supervolcano and what would happen if that magma actually exploded to the surface. Yellowstone is no ordinary volcano. It's a, quote, supervolcano, meaning its eruption could affect the entire planet. There's a giant caldera 70 kilometers across, hidden beneath Yellowstone National Park. Underground, there's a huge magma chamber, 2 layers filled with superheated molten rock and highly pressurized gas. It's a geological time bomb. Yellowstone has erupted 3 times in the last 2 million years. The last eruption, about 640,000 years ago, spewed 1,000 cubic kilometers of material, enough to bury a continent in volcanic ash. That eruption changed the landscape, forming a giant crater and disrupting the global climate for years. Scientists monitor Yellowstone closely. Micro-earthquakes, land subsidence, and geyser activity are all being monitored. However, so far there are no definitive signs of a major eruption. But remember, supervolcanoes don't necessarily erupt like ordinary volcanoes. A single fissure can trigger a global catastrophe. NASA even proposed a project to cool Yellowstone by drilling and injecting water to reduce the heat. However, such a project risks triggering an eruption. Researchers from Rice University and institutional partners discovered a gas-rich volatile cap at a depth of approximately 3.8 kilometers beneath the Yellowstone caldera. This layer consists of partially melted rock and gas within the pores of hard rock, approximately 14% porosity, that acts like a lid, allowing gas to slowly escape, a mechanism similar to steady breathing that reduces the risk of a sudden, large eruption. This model concludes that the magma reservoir remains active and dynamic, but the system is naturally able to slowly reduce internal pressure. Recent research indicates a shift in magmatic activity northeastward from the caldera. Electromagnetic geophysical monitoring indicates that basaltic and rhyolitic magmas are now predominantly located in the northeast, a previously understudied area. This provides a new perspective on understanding magma distribution beneath Yellowstone. The estimated volume is between 388 to 489 cubic kilometers, approximately half the volume of previous large caldera eruptions, approximately 1,000 cubic kilometers, highlighting the significant geological potential of the region. A joint team from the USGS and the University of Wyoming investigated the temporal relationship between basaltic eruptions in Henry's Fork caldera and rhyolitic eruptions in southern Yellowstone. Their findings suggest that basaltic eruptions in the surrounding region often act as precursors, heating the primary rhyolitic system, preparing for larger eruptions later. A young basaltic lava flow, approximately 35,000 years old, was also discovered, representing the most recent basaltic eruption in the Yellowstone zone, further enhancing the understanding of past activity. In August 2024, a new thermal vent emitting hot steam, approximately 171 degrees Fahrenheit / approximately 77 degrees C, was discovered in the Roadside Springs Zone, an area between Mammoth Hot Springs and Norris Geyser Basin. This vent creates a new grounding feature that is still being monitored for seasonal changes.